Welcome back, everyone. Today we're going to discuss about positive rational exponents. So let us begin. So these are all the examples that I want us to work on and investigate. Before we go on any further, I would just like to clarify some parts. On our exponential form, this right here is called the base, and this is your exponent. This is your rational exponent. On the rational exponent, this is your numerator and this is your denominator. So let's go ahead and see where those parts fall into when changed into radical form. So on the radical form, our base becomes the radicand. The radicand is the number that is found inside the radical sign. The numerator of the rational exponent becomes the exponent of your radicand, and the denominator becomes the index. Okay, so let's go ahead and evaluate this. I want you to think of a number that if you multiply by itself using as a factor 3 times will become an 8. We're going to deal with the exponent later, but for right now, think of that number. What number is it that if you multiply by itself using itself as a factor 3 times is an 8? Okay, great. That number is a 2. And then, of course, we're going to copy down the power or the exponent, which is a 2. So the answer here, when we evaluate the cube root of 8 raised to the second power, is a 4. Okay, so explaining further, how did we get that the cube root of 8 is a 2? This is the reason why. 2 times 2, 4 times 2 is 8. The number of times I use 2 as a factor is indicated by this index. So it's 3 times that I'm using it as a factor in order to have the radicand of 8. So therefore, after you get 2, which is the cube root of 8, you have to apply that power. And so that is going to be a 4. All right, now so let's work on this example. 32 raised to the power of 3/5. This is going to be your radicand, which is the number found inside the radical sign. The numerator is going to be the exponent, and then the denominator will be the index of your radical. All right, so this is read as the fifth root of 32 raised to a power of 3. So I want you to think of a number that if you multiply by itself and use it as a factor 5 times will become 32. So what is that number multiplied by itself used as a factor 5 times will be 32. Then after you generate that, you're going to now apply the power of 3. Very good. So the fifth root of 32 is a 2. Hold on. We still have not applied the power because I wanted to show you where that came from. All right. The fifth root of 32 is a 2. And that came from here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 2 multiplied and used as a factor 5 times is 32. And then after generating the fifth root of 32, that's when you go ahead and apply the power of 3. And so 2 raised to the third power is an 8. Why? Because 2 times 2 is 4 times 2 is 8. Therefore, the fifth root of 32 raised to the third power is 8. Now let us tackle this third example. 625 is your base. Your rational exponent is 3/4. 3 is your numerator, which when turned into the radical form is going to be the exponent of your radicand. And the denominator is 4, which is going to be your index. And so this is read as the fourth root of 625 raised to the power of 3. So I want you to pause for a while. Think of a number that if you multiply by itself using as a factor 4 times is going to turn to 625. After thinking about it, that's when you apply the exponent. All right, so very good. The fourth root of 625 is a 5. Why? Because of this. 5 times 5 is 25, times 5 is 125, times 5 is 625. Notice the relationship between the number of factors and the index. And then now after doing that, after generating that the fourth root of 625 is 5, That's when you apply the exponent of 3. So that would be 5 raised to the power of 3. And we can actually see 5 raised to the power of 3 somewhere here. So that's 5 times 5. 25 times 5 is 125. So 5 raised to the power of 3 is 125. For our last and final example, this is 16 raised to a power of 1/4. So once again, this base becomes the radicand, the rational exponent, the numerator is going to be your exponent of the radicand, and then the 4, which is the denominator, is going to be your index. Okay, so this is going to be read as the fourth root of 16. There is a power of 1 here, which I'm going to write in a bit. But for right now, I wanted to show you that the exponent of 1, we're not required to put it. An exponent of 1 is understood to be there if you don't see any exponent. For the purposes of our discussion, I'm going to put here that the exponent is 1. All right, so I want you to begin thinking of what is the fourth root of 16. What number is it that if you multiply by itself and use as a factor 4 times is going to become 16? So if your answer is 2, you are right, and this is the reason why. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So once again, how this is related, how the number of factors is related to the index is the number of factors, the index tells you the number of factors that you're going to have to use that number when you multiply it by itself. So now, after generating it, you're now going to apply the power, which in this case is a 1. So 2 to the power of 1 is just a 2. All right, for our next step, we're going to go ahead and consult Desmos and see if all these numbers are right. So I want you to take note. 8 to the 2/3, power of 2/3 is 4. 32 to the power of 3/5 is an 8. 625 to the power of 3/4 is 125. And 16 raised to the 1/4 power is a 2. Let's check Desmos. All right, so Desmos confirms all our solutions, and this concludes our lecture on positive rational exponents. I hope that you have learned a lot today.